Hello there, welcome back to yet another feedback video. Now, as always, we're here to improve. So what we need to have is we need to have the full working out. As always, we need to have the full explanation. Okay, now let's get ready. Now, this question here is about the graph. So we have velocity on the side, how fast it's going, and time, how long it takes. Now, which is faster, F or B? Now, where's F? So F is here, and B is here. Now we can see that F, it is at 7 meters per second, at B it is at 5 meters per second. So therefore, the one that is faster, it is F. Now why is F faster? So F is faster because, okay, so F has a velocity of 7 meters per second. How do we know? 7 meters per second, that's F. Done. Okay, so you get 1 mark for saying F, 1 mark for saying it is F. Reason why it's faster because it has a velocity of 7 and 7 is greater than 5 there. Now what is the total time the vehicle is speeding up in this journey? Okay, so the total time is speeding up in this journey. Now we want to identify where it is speeding up. So A, this is when it is speeding up. We can see it goes from 0 to 5, so speeding up. And then what else it is speeding up? So we can see E is also because E is going up. So E is speeding up. So it goes from 0 all the way to 7 here. Now, how long does this take? So therefore, we want to go from here. Okay, so this here. So from here to here, that's the time. And then from about here as well. So somewhere here then. So from here to here. Okay. Now this is 5. So we've got this one here. We've got this one here. So what we have is we need to count. Now what I'll do is I'll zoom in, so therefore you can actually see how I'm counting this. So I'll get rid of these lines there that I've drawn. Okay. Now let's do this. So we have so 2 squares. That's 1, 2, 3, 4, and then we have 5, isn't it? 5, 6, 7. Therefore, from this here, it takes 7 seconds. You can actually see how I counted this, isn't it? Because this is 5. Now, here we have 15, 15, 16, 17. So this is 17. Okay? So what we have is we have the time, that's 7 seconds from A plus, so 15 to 17, that's 2. So therefore the total time is 9 seconds. So now we have 9 seconds. Now the next question is how long was it stationary? Now stationary, again I'll get rid of all this because we've done this question now. Okay, so get rid of all this as well. Now stationary is when it is not moving. So not moving when the velocity, so stationary means velocity is 0. So therefore velocity 0 is D. So D is 0. So therefore it's from here and here. So these 2 times. So how long was it at these 2 times? You can actually see. So 2 boxes. So 1, 2, 1, 2. Therefore this is pretty much from, if you count it, so 10, 11, 12, 13. So therefore this is 13. So 13 to 15, that's 2 seconds. So 13 to 15, so this is equal to 2 seconds. So therefore 2 seconds. That's the answer. 2 seconds in this particular case. Okay? Because reason why, again, if you got this wrong, you can actually see this is the reason why. You can actually see that I've drawn it on the graph, I've counted on the graph, and this is the reason why in this case. Now let's zoom out to the next question. So draw a line for the bus to speed up this one for 10 seconds. So therefore now we need to draw, for 10 seconds. Okay, so for 10 seconds, pretty much from here to here, we need to draw. So from 0 to 10, we need to draw this. Now the time, the distance is, 0.5 meters per second per second. So why do we need to do this? So therefore, so in 1 second, we can see it's doing 0.5 meters per second. So therefore, in 10 seconds, how much will it be? So therefore, it will be 0.5 times 10. This will be 5 meters per second. So therefore, when it goes from 0, in 10 seconds, it's going to reach a velocity of 5. So therefore, it's going to be from here. So a straight line. Oops, let me just draw this properly. So it is a straight line. Okay, it's a straight line. So from 0 for 10 seconds, from 0 to 10 seconds, it goes straight to 5. So therefore, I'll fix this up again. So this has to be straight. Let me see. Alright, what I'll do, let me just pause the video. I'll come back to this. Okay, so we've drawn a straight line there, and then it continues. It continues at that particular speed. So therefore, it continues. So therefore, this will be flat because it continues at that particular speed throughout the journey. So it stays at 5 around the journey. So this is for question D. I'll write it there, D. Okay. Now draw force diagrams along for a constant velocity. Now this is a force diagram. So if you remember when we did terminal velocity, okay, so when the speed is constant, okay, so it means the forces are balanced. Okay, so there's nothing new there. So we are learning what we've done. It was we are drawing it. So we have a force diagram of the car. Again, so we have a car. Okay, so this is the car. Now it is going in the straight line, and it is constant velocity. Now, if you remember when we did terminal velocity, what we have is we have the air resistance. Now, since the car is going forward, so I'll call this here forward force. We need to have the air resistance which goes in the opposite direction. So I will draw this as a different color pen, red. Okay, so this is air resistance or friction. You can say friction. Now the forces need to be balanced. So therefore, the arrows are equal in length. Now, this is when we learn about terminal velocity. So remember lesson about terminal velocity. So instead of the car falling, so the car is moving in a straight line, but it is the same principle. So here, instead of having the weight pulling it down, we have force because it's driving forward. And remember, the arrows need to be equal. Why do they need to be equal in length? Because they are balanced. Now, why are they balanced? Because they are traveling at a constant speed. So remember, constant speed, this is the maximum speed you can go to. Okay, now this one here. Okay, so acceleration. So remember one thing we need to remember, acceleration is the gradient, which is change in y over change in x. Now when we did revision, we did talk about this. So therefore, we need to work out the gradient of a. So a equal to change y over change in x. B equal to change y over change in x. Sorry, so we're looking for C. C. E again, change y over change in x. And then G, change y over change in x. Equals, 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 divide, divide, divide. Now let's take a look at A. So A, it goes from 0 to 5, so therefore, so this is going to be 5, take it with 0. And how long does it take? It takes 10 seconds to do that. Okay, is it 10 seconds? Let me just check. No, actually it's from here, so here. So this is 7. Okay, so I need to fix this up, so therefore it's going to be 7. Therefore, the answer for this one is going to be 0.71 meters per second squared. Now, so you get 2 marks, 1, 2, because when you show me this, so this is the gradient, because you show me that you are doing the change y over change x. As you see, now C, it is this one here going down, so from 10, it goes from 10, so 11, 12, 13, so this is 13. Okay, again, so look, it goes from here and it goes down. So here is 5, it goes from 5 and it goes down to 0. So therefore, so this is going to be 0 because 0 is the final one, take away 5, and it takes how long? 13, take away 10, so therefore we have minus 5 over 3. This will give me minus 1.67 meters per second squared again. So I need to see this and then this for the answer. Now next one again we do E. E is the same thing, so E goes 15 and we go all the way to 15, 16, 17, 17 and it goes all the way to 7. So therefore it is going up. So therefore 7 take away 0, 17 take away 15, 7. Okay, so we just do the maths. So this will give me 3.5 meters per second squared. Again, 2 marks. So this is 1 and this here is a second mark. Okay, and then the last one from G against G, it goes to 0 and then start at 7. So it's 25, 26, 27, so 27. Alright, so let's do this. So therefore it is 0, take away 7, 27, take away 24, and the answer is minus 2.33 meters second squared. Okay, so 2 marks, this and this. Now, if you got this wrong, it means that you've forgotten how to work out acceleration. And if you got the numbers wrong, it means that you are pretty much misreading the values on the squares there. Okay, so be extremely careful. So this is here is the full working out in this case. Now let me just nicely write this down. Okay, so therefore we are not confused with the questions. Okay, so here we go. So this is the graph and this is the full working out for question 1, and this should give you all the points for that. Now let's move to this one. Now what we have is we have this thing here. So it says here we have a battery connected to the windmill and so on and so forth. Okay, so the wind turbine charge the battery. It's charging the battery. And the battery, okay, so it's charged the battery through wires, and battery drive the motor, and the motors to pull in so on and so forth. Now let's take what we have. So first of all, the wind turbine is transferring what? Energy. So we can see the wind. The wind is making this move. So the wind is moving. So the wind is moving. So if it's moving, so this is default going to be kinetic energy. Okay, transfer to what? What kind of energy does it transfer? Okay, so we can see here that there's wires. So look, it says here it is the battery is connected to the wind turbine. The turbine is charging the battery through wires. So wires, what goes in the wires? It goes electrical energy in the wires. Okay, electrical energy. Now, once it is charged up, the battery drives the motor. So what happens is once it's being charged up, so the electrical energy is converted to chemical energy, because the electrical energy, okay, goes to the motor. Right, goes to the motor. Right, so while the battery is charged up, so the electrical energy, it is transferred to chemical energy, because chemical energy is stored in the battery. Now, when the battery is switched on, it transfers the chemical energy in the battery to the motor. The motor is designed to transfer this into what? It's designed to transfer this into kinetic energy, because the motor, it's moving. The motor is rotating, so this thing turns. And now what happens is, when it turns, it is putting it, what happens? It transfers, the pulley transfers energy when it's putting it up. So where is it? Up. So if it's going up, so therefore it's going to be, so look, gravitational. So it says here, use the words to complete the sentences. So all the answers given to you there, you just need to use them properly. So gravitational potential energy. That's how it works. Okay. Again, if you got this wrong, this is the working out. Now we have the equation that's given to us, and we want to work out. So if we calculate the energy, so this is energy. I'll label this as E. Now the power is given to me here, 150, and time is there. So therefore, I need to work out energy. So I need to rearrange this. So I have power equal to energy divided by time. So this becomes energy equal to power times time, and this is power is 150 times 10. The answer is 1500 joules, 2 marks. So this is the full working out. Now, what energy is wasted when the motor is running? Now, when the motor is running, we can hear something. So this is sound energy. Sound, we can accept also thermal energy equal to wasted, because they are not useful. They're not useful for us. Okay, so the answer is this one. Any of these will give you the mark. Now, here's a good density questions. Now, we've done this before. Describe how the volume of the statue can be measured. Now, we've done this in general revision, yeah? So you need to be careful of this. First of all, okay, what we have fill a measuring cylinder with certain volume of water. Okay, and then what do? We gently lower the statue in the cylinder. So what happens is the water level rises up, and then we need to record the new volume. Okay, so volume of statue equals to difference in volume. Okay, so therefore we need to do bracket new volume. I'll zoom out a little bit. Take away original. So this here is original. Now, if you remember the diagram, if I have to draw diagrams, I have a measuring cylinder. Okay, put some water in it. Some water in it, for example, is going to be 500 ml, and then so this is step 1, step 2. Okay, so I put the statue in it. Okay, so now it's gone to 800 ml. So step 3, what I have to do is work out the difference. The difference here is 300 ml, and this is the volume. That's how you work out the volume. The question here is talking about how do you get the volume. Now, question here said determine using the figures whether the statue is made of gold or not. So show you're working out. So therefore, what we need to do is we need to use the equation. So therefore, density is mass divided by volume. Now the statue is what? The statue has a mass of 600 and a volume of 65. So therefore, it's going to be 600 grams divided by 65, and the answer is I get 9.21 grams cube. Now, I do not need to convert because all the answers here they are in grams. So now, what can I see? I can see that. So now I will say so density of statue is 9.2 grams, while gold has a density of, so gold has density of 19 grams per centimeter cube. Okay, so therefore, was the statue made of gold? No, because the densities are not the same, so they don't have the same densities. Okay, so this is how we get the correct answer. So first of all, you need to do your working out, a quick statement, and then we're done with the answer. Now next one here, so now this is energy. So when we're lifting it up, we are lifting it up, so we are going up. So this is gravitational potential energy. Now, what is the weight of the girder? Now, if you've forgotten the equation, so look at this. So this here, if I go back, if I go down, the equation is given to me here. Look, weight, mass, gravity. Okay, and what is the value for gravity? Look, gravity is 10. Therefore, the equation here is weight is equal to mass, gravity. Mass, what is the mass? Mass we know, look, 200. 200. Gravity is 10, so therefore 200. Now, weight is a force, so therefore it's Newton. So it's 200, 2000 Newton. Okay. Now, question here. So we have joules, energy. So this is E, energy, E. It takes 2 minutes of time. What is the power? Now, what is the equation for this one? What is the equation we need? So therefore, for this one, I need to go back to the other question. So look, this is the equation. This is the equation. Power is equal to energy over time. So therefore, I'll go back down here. So I have power is equal to energy over time. So energy is 49. Now remember, what do we have here? There is kilo. There's kilo. So kilo, I need 1, 2, 3. Okay, so 1000. Divide by. Okay. Now time. Now time is what? Look, time is in minutes. I need to convert this to seconds. So time 60 seconds. Okay, and then this will give me my answer to what I need to work out. So therefore, this will give me 408.33 recurring. So this is my answer in this case. Again, it's 4 marks. So it's 4 marks. The equation is given to you in pretty much the paper itself. You need to convert and then get the answer. You can actually see. Now here what we have, the engine has a power of this. Therefore the engine has power of this. What is the efficiency? Now we have the equation here. So therefore what I'll do is I'll write down the equation properly. We have efficiency equal to useful power divided by total power. We need to work out the efficiency equal to. Now what is the useful power? Now look at this. It says here, what is the useful power? So therefore, this number here is the useful power. So I'll take this. So therefore, 408 point dot dot divide by. Now what is the total power? The total power, if I read the question, the engine has a power of 5 kilowatts. So 5, how much is a kilo? How much is a kilo? 5,000. Okay, so this is how, even though I'm not quite sure what the question is asking, I'm using my logic, I'm using my brain to help me out. I'm staying awake, I'm staying controlled. Okay, I'm staying fixed. That's why we always need to fix ourselves. And the answer is 0.082. So 0.082. So this is the efficiency. Okay, so the useful power, we've calculated it, and the total power is given to us, and all we're doing is using the equation that we have already and the numbers that we're working out. So look, there's nothing I need to remember. Okay, because all the equations given to me, I just need to remember, okay, I need to convert them back. Okay, now what form is the energy wasted? So here, what we have here is this thing is putting it up, is lifting it up. Now how will energy be wasted? Of course, one's going to be sound, because you can hear the machine going crazy. You can hear that. Or the other one could be thermal, because there'll be some heat in the engine. So pretty much any of these answer will do. Now this one again, energy. What we have is power equal to energy over time. Rearrange energy is equal to power times time. Now power is to. Now we need to convert this. We need to convert this. So we have 2 hours. How much is 2 hours? So how much is 2 hours? How much is 2 hours in seconds? So 2 hours, how much is it in seconds? So let's do minutes times 60. So this gives me 120 minutes plus the 20. So this gives me 140 minutes. So now I have 140 minutes. I need to convert this again. So this is minutes. I need to times by 60 to get seconds. So times 60 to get in seconds. Okay, so I need to times 60 to get in seconds, because I need time is always in seconds. So therefore energy is equal to so 1,100,000. What is it? 100? Okay, 1,008,000 joules. Again, so you can actually see the equation. They are given to us, and I'm able to use it. So there's nothing crazy going on there. Now again, this is terminal velocity. We've done this before. So it's dropping. So if it's dropping down, so this here is the weight. Okay. Now what is weight? Again, weight is force due to gravity. Now we are falling, so therefore X is going to be air resistance. Therefore X air resistance. And this is the possible to answer that we can have. Again, if you got this wrong, so this, I'll put this bracket terminal. So this is from the topic of right in the corner, so we're not velocity. So this is from the topic there. Again, so you've got this wrong. So this is the whole thing is your purple pen. Okay, you're showing that you understand. Now, explain why force X act upward. Now, air resistance. So X is, we'll recognize is air resistance. Now, air resistance, what does it do? It always opposes motion. Slash motion means movement. Okay, so when you run, you feel the air hitting your face. So always against you. So that's why it acts upwards, because always against motion. So you are falling, so therefore it goes against you. You are running, it goes against you. Now, what happens if it is unbalanced? Which force will be greater? Now, if it's unbalanced, it means that Y, which is the weight, will be greater. Okay, because you're falling, you fall faster. Now, how does this affect the? Okay, so therefore, so weight. Okay, so let's have a look. So what I will do is I will do the following. So if it's unbalanced, it means that the air resistance, okay, is less than the weight. Okay, so therefore it's less than the weight. So therefore the weight is bigger. So if it's less, the weight is bigger. So therefore what we have is okay, so sky diver accelerates downwards. Okay, because the air resistance is less than the weight, therefore you accelerate downwards, you go down faster. Now here, what we got? So which one is true? So we got the parachute is open. So what happened is when the parachute opened, the air resistance it goes up massively, because that's what happened, because all the air gets trapped in. Okay, because lots of air are trapped due to large surface area. Again, so this is the working out if you got this incorrect. So therefore, the X increases. Now, Y, what happened? Y is still the same, because Y is the weight. So Y is the weight. And the person does not change. The person doesn't get bigger. Okay, so here, person does not get big. Does not get bigger. So it stays the same because it's bigger. Now, the speed of this will eventually decrease, because this slows it down massively. Yeah, isn't it? So this is the answer, and this is the full working out. Make sure that if you got this wrong, it needs to be fully done. I'll check you guys out. Now, here we go. Again, so this is the equation. So number 6, look, the equation is there. The equation is there given to us. Everything's connected, like the cycle of life. So what is, okay, so W equal to M times G. We're looking for weight, so therefore 1.1 times 10. So this is 11 Newton, done. Now what is the gravitational field? So we have W is equal to mg. I need to rearrange for G, so G is equal to W over M. Weight is unknown, it's 1.6. What is the M? Okay, is 11.1. Now remember, M, mass, does not change. Okay, weight changes as it depends on gravity. Okay, so therefore the answer is 1.45 Newton per kg. Now why is it Newton per kg? Because weight is Newton, mass is kg, so therefore I have this one, and this is the full working out. Make sure that you understand to figure this out properly. Now here again, just working out weight. Look, I've done everything. Weight, mass times gravity, 0.06 times 10, 0.6 Newton. The answer is 0.6 Newton. Give the unit. Okay, nice one. Now the toy is hovering stationary in mid-air, so the force is what? The same. Now again, this is like terminal velocity again. Terminal velocity question. So it is stationary in mid-air, so it's not moving. So not moving. So therefore the forces are balanced, so therefore it needs to be the same. Now what does the word acceleration mean? So we've done this. Acceleration is rate of change of velocity. Okay, so this is the word. So rate of change of velocity. Now if you write the word, if you write the equation, so acceleration is equal to final velocity take away initial velocity over time, then you should also get the mark. Now which direction of the resultant force on the falling object? Now the object is falling, so therefore the force is down. The force is downward because it's falling. Okay, now does momentum increase or decrease in this case? Now this is a good question. So the momentum increases. Now why does it increase? Is because so there's a force that pull it down, yeah? So when the force pulls down, it means it is accelerating. So give a reason for that. It is accelerating. So accelerates as its velocity increases. Because the velocity, now remember, acceleration is the rate of change of velocity, is the change velocity. Now if the velocity is increasing, it means it's changing. Therefore if the velocity is changing, it means it accelerates. If it's accelerates, the momentum goes up. Okay, now let's do this one again. So the quantity of a speed graph, let's plot the graph. So graph speed and time. Okay, so we go. Now the area is the distance. The area is the distance. Okay, now remember, if I got this wrong, so area is equal to, so the area is pretty much the triangle, so which is half base height, which is half times the speed times time, which is the distance. Now, which is not true? Which one's not true? Weight is the force acting, that's correct. Weight is measured in kilograms, correct. Weight can be measured in Newton, correct. Weight is measured in kilograms, incorrect. Therefore, the answer is D. Okay, so now this one, what we have. Now, so from here to here, it decreases. So therefore, it decreases and then stays the same. So here, okay, so here it goes down and then stays the same. So therefore, which one is correct? So moving at constant deceleration and then steady speed. Okay, yeah, because it is constant deceleration, it decelerates because it's getting slower, and then move at a steady speed. Steady speed means constant speed. Okay. Now, if you got this wrong, we need to add the stuff here. So same speed on the graph, and this is constant deceleration. Okay, again, deceleration. Now, which one is correct about iceberg? Now, iceberg, they are lighter than water. Is that correct? Are they lighter than water? Are they lighter than water? No, they're not lighter than water. Iceberg have a larger density than water. No. If they have a large density, they're going to sink. It has a larger density than fresh water. No. Iceberg are less dense than silt water. Yes, because if you remember, we got the sea, we got the iceberg there. Okay, so this is the iceberg. Okay, so density. So this is true. You got sea, water, and this is ice. Okay, so we've got the seawater. Okay, so why does this iceberg float? Because they have less dense, than seawater. Now, this one here, blah 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 blah, the inside out, showing which one loses heat the fastest. Okay, now this one's the same, so it can't be this one. Okay, now this one, the difference, right here, difference, so this one's difference is equal to 10. Okay, this one is 20. This one, what's the difference here? Okay, 30. Therefore, this one has more difference. Therefore, this one will lose heat the fastest. Now, for example, if you're hot, okay, for example, if you're hot, you go outside, your heat goes away. Now, this one here is volume. So volume is 2 centimeter times 2 centimeter times 2 centimeter. So 2 times 2 times 2 is 8 centimeter, so centimeter cube, because there's 3 of them. Therefore, the answer is D. Again, if you got this wrong, this is the full working out. You fix everything properly, all the working out. So you will know now, if you listen to me, you know that now how easily we can get all the points. How easily we get all the points. So we need to stay awake. We need to stay fixed. We need to fix ourselves. We need to control ourselves. And hopefully, all of this will click. Peace out.